Because can I just make a point about that? I might ask the question exactly the way I did for you. But there's someone here who has difficulty. I might have got 5 of these world map things. Does that help you? I don't have to hang around there and answer a whole lot of questions. That's all I needed to do. So it's a nice suggestion. And then they said, well, I still can't do it. Then you do. Oh, what do you think those things mean? So, all right, has got any other suggestions? Yeah. So can you find a way to look at what time it is in Fiji, and can you use the net in some way to help you or something? The one before, yeah. Oh, yeah. No, it is. It is. It is an easy one because it's just giving them a prompt, and it's okay. Now I found the time in Fiji. Well, there's other time that might be other places that might be that time, so you can then get them back onto the task to do that. All right, what about extending prompt? What might you say a kid's got the answer right? Yeah, it's going to be, Fiji and New Zealand, and it's going to be Ireland or wherever it is.
Why is it not the same time?
Yeah, why is it not the same time? Yeah, that's a good question, actually. But
why are the days different?
say it again?
One will be on Tuesday and one will be on Wednesday.
Yeah, why are the days different? Yeah, no, that's actually one of the things that I found that always confuses kids when you say it's a different day now in America, if I'm on the right. Yep, yeah. Yeah, that's right. In Europe, it's probably...
You could ask where you fly to and land.
Yeah, so where can you fly to and land? So just in a sense, just enriching the question a little bit, making it a little bit of a challenge, a little bit of a puzzle. It's a way of engaging the kids. Okay, now here's a problem. Can you first work on this by yourself? So the probability of a person on a train reading a newspaper is 0.6. The probability of a person on a train wearing a coat is 0.7. How many people might be on the train, and how many people without a coat are not reading a newspaper? Did anyone make a decision about how many people might be on the train and maybe justify why they chose that number? Would someone like to have a guess? So you're going to say 240 people. Okay, so and why did you say that number? Okay, so there might be 240 people, so we'll put that there. So if I had a whiteboard, I'd write 240 people. No, it actually doesn't matter, but there might be some relevant reasons for choosing particular numbers. Who chose another number? 100. Okay, and why did you choose 100? Yeah, so the 0.6 and 0.7 will be easy. So can we just, for the purposes of the answer, say pretend it's 100? It could be anything, but we'll pretend it's 100. Okay. Who's got a suggestion of how we will now work out the answer to the second question?
Assuming the events to start.
Yeah.
To make it a lot easier.
Yeah.
Probability of not wearing a coat would be 0.3. Probability of not reading newspaper would be 0.4. The independent events, the intersection of those two is 0.3 times 0.4. Multiplied by 12 people are not wearing coats.
Okay, so by that method using conditional probabilities, assuming independent events, and by the way, we probably can assume independent events unless there is some connection that people who've got coats are more likely to buy newspapers. We're not, yeah, so they can afford a coat and therefore they can afford a newspaper. Yeah. Okay, so that was, if you like, an analytical method that we would have to do that. Who did it by a different method? Yes. So to explain the Markov chain. Yeah.
42 reading and 18 reading without code,
12. And so you've got the same answer to do that. But one of the interesting issues is this is actually a two-way table. Now the Markov change isn't necessarily a two-way table, is it? It could be any. Yeah. Did anyone do it by using a two-way table? Now, so the same sort of thing. So the tree diagram. Do you want to just talk through the tree diagram so that?
Yeah, I just assumed that started off with a dot and I had reading and non-reading.
So reading and non-reading.
And then for each one of those I had coat and not coat.
So coat and not coat.
And the one down the bottom gave me reading and coat, and I multiplied the probability to each.
Yeah. And all I have to do is add to 100 at the end to get you 100 people to do that. The total of the coat and the not coat, I now forget what they were. Was it the coat 0.6? Okay, with the 100, the total of the two numbers there have to be 60. No, we need that. Now I got confused. The total of the people who are wearing a coat is going to be 60. The total of the people who are reading a newspaper is going to be 70. And the total of all the numbers is going to be 100. And so we have to work out what combinations can we put in there as a way of getting the possibilities. Now, in a sense, David's suggestion and Christina's suggestion are formal ways of finding the probability, but that's, if you like, a basic way that even Year 7 kids could do, to do that. Okay, so that... Okay. Can you talk about now, where would you ask that question, by the way? That's a Year 10 or 11 question, isn't it? Okay. Can you actually talk about, okay, what might be the enabling prompts and what might be the extending prompts for that question? Can I just say what happened then, that was actually sort of quite interesting, is that it seemed like the groups that I was listening to started talking about the range of strategies, which is why you asked this question in the first place, so that you can actually get the kids to connect the intuitive strategies with the formal strategies and see, well, okay, the formal strategies can actually help us in a question that's quite complex. But who's got some suggestions about how we might help the kids who are experiencing difficulty? Yeah, so yeah. So we can actually ask prompt questions. You know, can you do both? You know, to do that. Okay. What are the possible combinations? So we can actually give them prompts like that. All right. What's another question? Another suggestion? How can we help? Yeah. So okay. Just assume there's 100. It might be any number, but work on 100. So let's save one of the problems.
Just break the problem down into first going, okay, well, how many people are reading newspapers?
Yeah.
Tell me how many that is.
Yeah, so that just break it down into parts so that how many people are reading newspapers. Yeah? Any other suggestions? And you might even say, forget the raincoats, just focus on the newspapers for the minute. You know, how many people might there be? How many people are reading a newspaper? So to do that. And so we could actually do it in parts. Any other suggestions? Those, by the way, are all fine for how do we actually help the kid get into the task. Okay, then the other question is, how might you extend the kids get finished? Because, by the way, that's the sort of problem I'd use for a whole lesson or something. I might have one or two other ones at the end, but you know, I'd let kids work on it for quite a while and struggle through the business and the connections. But some kids will finish quickly. So what are we going to say to them? Yeah, it doesn't make a difference if you change the number of people on the train. Can you find a rule where it doesn't matter whether the number of people? Yeah, all right. What's another suggestion?
Can you introduce another variable?
Yeah, so maybe, you know, who's got the probability of wearing shoes is 0.9, so standing and sitting or something, yeah. So we can actually have another variable to make it so that, to make it more complex.